Hello, everyone. This is Shane with the Tesseract Order of Magi, and I'm joined with Michael Trone, who is a brilliant young man who's been studying physics for the last 16 years. He studies biblical physics and genetics and knows a great deal about how the science of the universe works. So, what we're going to talk about today with Mr. Trone is light. Now, Mr. Trone, I get a question a lot, and it is always the same thing, is that how can we see starlight, which are billions of miles away, and that the speed of light, this light does not reach us for tens of thousands of years. And so people don't understand how, if the world is so young, that we can see starlight.
There's a lot of factors that play into that. A lot of people commonly think that something called the Doppler effect is happening to stars and starlight. Whereas if you have sound waves, anybody that's familiar with the Doppler effect knows that if you have sound waves and you hear like an ambulance driving towards you on the road, and the pitch will sound closer together while it's coming at you because the sound waves in front are compressing. And then as it goes past, the pitch elongates and you'll hear a longer pitch because the wave behind the ambulance will be spreading out essentially. And that's commonly what people refer to as the cause for the red shift and the blue shift of stars. But the actual reason that we have found, multiple physicists in the plasmatic sciences have been doing research in something called stochastic electrodynamics. Most people refer to plasmatic physics and they call it QED, which is quantized electrodynamics. Stochastic just means random. And in the studies of random and the randomness in the plasmatic sciences, they found something that originally was called Planck's constant. It's represented as a little h in physics terms. And in 1901, Maxwell Planck wrote his original paper, and then again wrote another one in 1909, where he refers to this Planck's constant. Now, what people commonly think was his original plan for his paper was to discover Planck's constant, but it actually was discovered by accident. And what Planck's constant is if you take a vacuum, a section of space, and you create a vacuum, and then not just a vacuum where you evacuate the gases, but you also cool it to absolute zero. This is known as a bare vacuum. Now, this bare vacuum, what we found is that inside of this space that's supposed to have nothing, no heat, no energy, no nothing, that in 1 cubic centimeter of space, there is more energy than our sun has output in its entire lifetime. And actually, the numbers are pretty staggering because the amount of energetic output we get from this 1 square inch of space is not just more than our star has produced in its entire lifetime, but every star in the Milky Way galaxy, all as well, all of the energy that those stars have produced in their entire lifetime. Now, this Planck's constant they're waves, they're frequency waves that travel in a subatomic setting. So they're smaller than the smallest pieces in atoms, smaller than gluons and quarks and things like that. And there are billions times billions of these in every little inch of vacuous space. It permeates everything around us. The human body, all of the atoms in our body, our molecular structure, every cell, and all of the equipment we use to detect things also have this Planck's constant permeating throughout all of their subatomic particles as well. So that's the reason why you don't feel this massive amount of energy, is because it is literally inside of you everywhere. And this massive amount of energy even though it changes over time, and we've noticed that this number has gotten greater and greater, that the amount of energy that you find in this bare vacuum, we don't notice the change for the exact same reason that you don't really notice much of a change, aside from your ears really popping, a difference in elevation when you go up and down on the earth, even though the atmospheric pressure changes as you increase in elevation. So, but we don't feel that because it is pretty much even across our whole body. Well, the same thing's true in all of our cells. It's pretty much evenly displaced, this Planck's constant, throughout everything. Now, the speed of light is dependent on this constant. So what we have found that is back at the beginnings of what most physicists will refer to as the Big Bang, the speed of light was actually traveling 3 million times faster than it currently is traveling now. And the way we can tell this is in 1647, Olaf Romer, using moons around Jupiter, was able to postulate what he thought the speed of light was and calculate it based on the mathematics of a moon that's traveling around Jupiter. Now, with the change in planetary orbits, lunar orbits, and cosmic events like asteroids and things like that, these elliptical orbits are not always the same. So to reproduce the same experiment that Olaf Romer did in 1647 would be very difficult. But as time went on, other people were able to simulate similar tests in different settings. In 1647, the speed of light that Olaf Romer came up with was 317,000 kilometers per second, with an error margin of plus or minus 5,400 kilometers per second. So a pretty giant error band. But fast forward 100 years into the 1700s, another experiment was done, and it found the speed of light to be 310,000 kilometers per second with an error margin of less than 1,000 kilometers per second in either direction. Now, 100 years later, with a narrower error band, we find that 1,000 kilometers per second error band, north or south of this speed, cannot equate for the original speed of light that was calculated by Olaf Romer over 100 years before. And in the past 300 years, we have calculated the speed of light over 275 times. And in every single instance, the speed of light is slowing down. If you put them all on a graph, which I do have one of the graphs, I can't show it right now, but if you show them all on a graph, it shows that there is a regression curve in the speed of light. Now, we also noticed that Planck's constant, from the very first time that it was discovered in measurable quantities, just after Maxwell Planck wrote his paper, the Planck's constant was increasing instead of staying constant, as the name would make you think. It doesn't stay constant, and it is changing as well, and it is becoming more intense while the speed of light is becoming less intense. Now, I'm sure everybody's wondering, I went on a very long, roundabout way to get to this explanation for why stars in space do what's called the red and the blue shift. Now, we notice that light in its more energetic form, meaning that it is having to interact with more particles more often, so it is essentially using more energy and transferring more energy among the particles that it encounters. Now, a lot of you are probably thinking, oh, well, light can't be affected by particles. But what we have are called virtual particle pairs. Planck's constant is a creation of particle pairs from nothing. As space stretches, just like with a rubber band, it essentially, you put your own energy into that rubber band as you stretch it, and then when you release it, that's released in kinetic energy. Well, the same thing is happening with the fabric of space-time, is that as it is stretching, and we know that every galaxy is moving away from each other, none of them are getting closer together, even though they're traveling great distances. Um, and because they're all moving apart in equal directions, all at the same time, proves that space is expanding like a rubber balloon that's being blown up.
I want to
Throwback
interject here
to
just for a
Barry
second.
Setterfield.
I was going to say
Go
that
ahead.
Isaiah says that, thus says God, Yahuwah, who created the heavens and stretched them out, who spread out the earth and what comes from it, who gives breath to the people on it and spirit to those who walk in it. And I was thinking that in the Hebrew, it might not be that God not only stretched out the heavens, but it could be that he's still stretching them out. What do you think?
You're actually way ahead of me. I was gonna get to that. I was actually gonna reference that one as well as one in Job, that where it talks about he alone spreadeth out the heavens and gives his energy into them. It's a Job 9. I might not be quoting the exact verse, but uh, yeah. So you're spot on in your assertion of the information. Exactly as Isaiah says, there is that he spreads them out, but the Hebrew word behind it shows a continual action. So the word that's used there means continual action, as in still stretching the heavens. And we know that space is still stretching, which means that the hand of God is still putting his energy into it as he stretches it in the form of Planck's constant or 0 point energy. So, 0 point energy is that Planck's constant. There are little virtual particle pairs that as space stretches, more and more of them appear, and they produce energy as they appear. Now, these particles aren't really like atoms. They're subatomic particles that are beyond small and beyond large in energy. And every time a pair of these is created, these particle pairs actually interact with light and electrons and things that you would normally associate with zero rest mass, are interacting with these particle pairs every time they run into one. And what happens? So what happens in an atom is when an electron runs into one of these particle pairs, it gives off a burst, and a burst of energy. And so as the electron is knocked out of its orbit by this virtual particle pair, it releases a photon, and then the electron snaps back into place. Now, the more energy that is, the more energetic the 0 point energy that hits that electron, releasing the photon when they interact, then actually it will create a more and more blue light. So this actually we find shifts, not stars based on distance, but based on age. So it, even though they're far away, right, billions of light years away, the speed of light was moving 3 million times faster at the beginning of creation. At the time of Abraham, it was moving at probably 3,000 times faster than it currently is. And so that speed of light, if speed of light right now is roughly 300,000 kilometers per second, you multiply that by 3 million times, then that light that was billions of light years away may only take just a few thousand years to reach us. And again, this effect of the 0 point energy also has an effect on how we measure time. Atomic clocks tick based on how many revolutions an electron makes around a specific atomic structure. Some atomic clocks will use uridium, some atomic clocks will use cesium. It depends on what age that atomic clock is. Now, the electron is having to interact with more and more of these particle pairs in its elliptical loop around the nucleus in the electron cloud. So every time it's bumped from its path and releases a photon, it has to move back to the path that it was on and continue around, meaning that it takes more time for that revolution to occur because it's interacting with more particle pairs on its path. Now, a side effect of the change in the speed of light is that synapses in human brains fire slower. Electrical impulses from the tip of your toe to your brain take longer now than they would have at the time of Adam and Eve. 3 million times faster the speed of light, meaning that even if, let's estimate how tall Adam and Eve could be. Let's say that they're taller than the average human now. Even if Adam and Eve were 7 or 8 feet tall, which we don't have any evidence for, but I'm using it as an example, it wouldn't take as long for that impulse to get from their foot to their brain. So they would have been more sure-footed, been able to react faster, been able to do every single thing that we want to do faster. They would have naturally been able to do that faster. In today's day and age, we like to use bionics and things like that to try to make us faster and better. But they were just naturally faster, better. And this also meant stronger muscles. This also meant eyes that could see further because the cone receptors were getting more detailed information. Cone receptors wouldn't have had to be so long like they are now. They would have been able to be much shorter, allowing for more light inlet. And the reactions inside your retina and cornea could turn images into your brain very quickly for very fast hand-eye coordination. And this is just scientifically proven based on the synapses firing and how many synapses can fire in what sort of
So, do
distance of
you
time.
think that
So
people would be able to process and analyze information faster, learn faster, and perhaps, just discover advanced mathematics and things of that nature?
it would have been second nature for them for advanced mathematics. So here's where we're going to go into the inside workings of our body. Inside your brain, there is a receptor that is in the front right part of your brain. And this receptor interprets the noises that you hear as language for you to understand. So, how it works is your brain works like a computer. Any sort of quantum computing, they measure the amount of electrons that are fired by a synapse, and it reads those electrons as a specific number, letter, noise, things like that. Now, there is a pathway between the back of your brain and your spinal cord and that specific gland in your brain that's about 3 inches long. Um, and that 3 inches at this current speed of light, based on all of the synapses that have to fire through that pathway, it is relatively slow when you compare CAT and MRI scans from earlier MRIs just 10 to 15 years ago. We're seeing a slowing in the firing inside the brain. Now, because our brain picks things up in a sort of Morse code, our brain is naturally coded for understanding mathematics. Because our brain and our nervous system does math every single time we move a finger or move a hand or make a thought or speak. Everything has to be interpreted by our brain via mathematics. We have to think about it now, but at the time of Adam and Eve, their brain capacity would have been 3 million times faster and better than ours, meaning they would have more storage information. The average human has about 500 terabytes of storage inside their brain. If you want to acute equivalency, that would be a good equivalency for how much storage we have in the human brain. storage would have been more abundant because of less synapses having to fire to think, because they move faster. So I would say 3 million times more storage than that would have been in Adam and Eve's brain at the time that they were kicked from the garden. So math would have been so second nature to them that they would have probably had the capacity, the brain capacity, to count the synapses that are firing inside of their own brain, and had conscious feeling of that occurring as it occurred. So I'm gonna use I'm essentially going to use some of the mathematics that I've already done. I don't have them in front of me to refer to, but I'm just going to go off of my memory. So if we equate the size of our universe, and we equate the speed at which all galaxies are moving away from each other, and the amassing of this 0 point energy that is amassing in a bare vacuum throughout all of space, we're coming to a number that is similar to Moore's law for electrical computing. Moore's law says that transistors can only get so small, and once they get to a certain point, we're talking about things that are the size of single atoms. And once you have a transistor that's only 1 or 2 atoms thick, you can't shave it down and make it any smaller, meaning you have to pack more transistors onto that board to get the same computing power. Now, we're starting to get to that point very close. We're getting very close to that point in time in which no more virtual particle pairs can fit in the space of our universe. So there are so many virtual particle pairs being created right now, something like 10 to the positive 64th power virtual particle pairs are created every second. And that's in and around everything around you per cubic inch of space. And space is everywhere. And what this is doing is this is actually, because it's slowing the speed of light, it's slowing time. Now, there's a verse, I don't know who reads apocryphal books or anything like that, but in 4th Ezra, there's a verse in there where Ezra says that in the beginning, there was no fast, and in the end, there will be no slow. Now, Hebrew Atbash says that if you look at things under a Hebrew Atbash code, which is basically turning the Hebrew alphabet over on itself, and you use that lens to look at certain things, you can see that that verse in Ezra is actually flipped. And if you look at it with that sort of lens, you see that it says that there's not going to be any slow in the end times, but physics says that time is slowing down. So what does that mean? Well, because time is slowing down, that means for us, in our perception, events that would have taken hundreds of years, if not thousands of years at the beginning, will now occur much faster and in a closer cluster of events, because time is moving slower, but our perception of time is the same. So what would have seemed to Adam and Eve to take 150 to 200 years for us could just be a year. And we are privileged to live in this time in God's creation because we're coming close to what's called the consummation of times. That word that is used multiple times throughout the Tanakh and in the Brit Hadashah of the consummation of the times. Another version says the fullness of the Gentiles. And there's lots of different ways that it's represented, but if you look at that word that's used for consummation of times, it's actually 2 Hebrew words. I don't have them in front of me, but it means time stops moving in the direction that it's moving. If God lets go of the fabric of space, well, then he's no longer putting his energy into it, and it's going to have to retract. All of space that is stretched out this far will then reverse. It's going to essentially release the energy that's been stored back into the universe. At this time, when those things start to occur, Um, Light will start moving faster. Humans will be able to think more. Humans may also be able to live longer at that point, because now the time that would have taken a certain length of time is now shortening. And so longer lives may be possible. I'm not going to guarantee that, but um, and what I've noticed is that we're coming close to what's known as the third day. Hosea prophecy talks about today as like 1,000 years, 1,000 years is to a day. And if you equate atomic time, then you're going to come up with numbers that are astronomical, millions of years. But if you take orbital time, and the Magi do this very well, basing all of their times off of orbital stuff, and that's exactly what God says that we're supposed to do, is use the sun, the moon, and the stars for times and seasons and signs and things like that. So, based on the math that I find, and from the death of Yeshua, whatever time Yeshua died, we move 1,000 years as one day, and another 1,000 years is 2 days. And that brings us, some experts say that it's 2030, some say that it's 2028, some say that it's 2027. But no matter where you look, that number is within the next 10 years. And physics dictates that a certain point, like Moore's law, no more virtual particle pairs can be created. And a famous physicist hypothesized in 1849, and I forget his name, I forget what his name was, but he hypothesized that this point in time, when the fabric of space-time can no longer stretch, and this is pre-Einstein, mind you, at a certain point in time, when it can no longer stretch, and the mathematics can no longer be calculated into the stretching of space-time, when it releases, it will be biblical catastrophic events worldwide. And another famous physicist, who actually didn't get a lot of recognition for his work, but Nikola Tesla, who was an electrical engineer, an amazing mind, he hypothesized that that end was going to come in 2029. There's a couple of autobiographies, or not autobiographies, but biographies of Nikola Tesla, in which he talks about when he thinks the electromagnetic energy throughout all of space will not be able to amass any longer, and it will all release. And his date was 2029. So either way you look at it, we're getting very close to that date.
Uh, what about the atomic clocks? What can you tell us about those and how they're not not adding up to our relative time?
Okay, so I talked about an atomic clock a minute ago. It's based on how many revolutions an electron does around a circuit of a nuclei. Now, with this change in the speed of light, there's a change in that measurement. If it was moving 3 million times faster at the beginning of time, that means that, let's say, a billion, or let's use a small number. Let's say it only makes 100 revolutions in 1 second. Now multiply that by 3 million. That is now 300 million revolutions per second around that nucleus. So atomic clocks would have been moving so fast, they wouldn't have been feasible to use to keep time. Now, the change happens over such a long period of time that most people don't notice it. But now, with atomic clocks having been used worldwide to keep time, like the Denver atomic clock, there's one in Alaska, there's one in California, and they are off, not from each other, but from orbital time. So the Magi look back very long distances at series of events and star position and things like that during specific events. And one event that that really sticks out is the event during the time of Yeshua. we have been able to accurately calculate the specific celestial bodies that were in space that caused the Magi sign, the sign that they knew Yeshua's birth was coming. And with that specific sign, we can also pinpoint a relative date range. Now, what's weird is that exact same sign, according to physicists who use atomic clocks to date things, their dating of that same event that we know happened roughly 2,000 years ago, they date it to over 250,000 years ago. So using that same sort of math, you can calculate how long ago it actually was based on orbital time. But if you use atomic time, you get these astronomically high numbers of 250,000 years. Or another thing is, during Noah's flood, a few sequences, they're called mega sequences, occurred where the earth flooded, deposits of mud and sand and things like that were laid down evenly across the whole earth. Anybody that's into geology can look this information up for themselves. But we date the Cassica supersequence as happening right around 300 million years ago. Yet we know, based on biblical time as well as orbital time, that that only occurred roughly 4,500 years ago. Or I mean, roughly 6,500 years ago, someplace in there. My math is probably off on those dates, but we know that it occurred within the last 7,000 years. But the mathematics behind when those sequences were actually laid down, according to atomic dating, atomic time, is 300 million years ago, which honestly isn't feasible based on how deep down they are and the erosion that happens. The best way to look at them is the Grand Canyon. The way that the Grand Canyon is laid down, you can actually specifically see each layer and take pieces of it. And we do what's called carbon dating, which is nowhere near accurate. I could carbon date a pin that's sitting on my desk and it'll say it's 15,000 years old. So carbon dating is not an accurate way of dating things. But yeah, time has been, because time is changing atomically, the way humans perceive time is also changing. So because atomic clock rates are ticking slower and slower, and the speed of light is getting slower and slower, the 0 point energy is getting larger and larger in every bit of space. This causes a difference between what we actually know time should be and what physicists and geologists are hypothesizing time is. There are a few physicists out there that don't, Barry Setterfield being one of them. Barry Setterfield was part of the Setterfield-Norman experiment, where they plotted speed of light values over the last 300 years, compiling over 250 different tests for the speed of light and proving without a shadow of a doubt that the speed of light was slowing down. So throwback to them, they're awesome guys, and the late great Chuck Missler all uncovered a wealth of information so that we, people who want truth, can really find accurate or very close to accurate dates based on orbital times.
Okay. A couple things you're saying that I'm just trying to relate back to scripture here. 2 Peter 3:10, it says, "But the day of the Lord will come like a thief. On that day the heavens will pass away with a loud noise." Could that be your rubber band
Yes.
crashing and everything, and the heavens roll back as a scroll? And
Yes. Yes, exactly. 100%. That is what that verse is referring to, is the release of kinetic energy and built up 0 point throughout space.
And also, there's another scripture, Revelation 10, verse 6. It says, "And swear by him that lives forever and ever, who created heaven and the things that are therein, and the earth and the things that are therein, and the sea and the things that are therein, that there should be time no longer." It's interesting how it says that, but of course you can read that a different way. But with no time, that's something interesting. Now, if light was slowing down and time just slowed way down too, isn't there a point in which light would slow down so much that it would become something physical that intangible that you can touch?
Oh, 100%. Not only be able to touch it, but you would be able to manipulate it, to shape it and things like that. That's actually a hypothesis by multiple different physicists who are in this slowing of the speed of light sort of setting. And we see that in the Bible that by his voice all things were created, and he saw the light and he saw that it was good, and he separated the light from the darkness. Now, what we don't understand in our dimensional construct is the being able to hold light in your hand. But if light slowed down to, let's say, it was only moving at 5 kilometers an hour versus 300,000 kilometers per second, well, now you'd be able to go over and touch that photon. And yes, it wouldn't have rest mass, but it would have physicality to it. We live in a simulated, a lot of people hypothesize we live in a simulated environment. Well, God spoke this into existence and he holds it. He puts his energy into it. He stretches the heavens. So it wouldn't be a stretch to say that all of this being the creation of God is just a simulation for him, by him, through him. So being able to manipulate light in your hand would be something you wouldn't understand as a fourth dimensional creature. But if light slowed down enough, then you once you saw it done, you'd understand how it was done, right?
I have another idea about the concept of light slowing down, that when the New Jerusalem comes down from heaven, and the scripture says outside are the dogs, speaking about evil people, and it lists off a few types of evil people. It says they are outside of the city in the darkness, and Yeshua said that they would be cast out into outer darkness. Is that to say that the whole world would become dark because of something to do with physics, and that the New Jerusalem would be the only source of light with God and Yeshua?
So at the point when light slows down that much, to where we would be able to physically see it, and at the point in which it snaps back, the entire space-time stops stretching out and starts retracting. Well, for a while, light will be essentially, it won't be luminous because it doesn't move fast enough. So light will not emit light in a sense that because it's moving too slow. So there would need to be a source of light in the time in which it takes light to speed back up to where it can be used.
And that brings me to another interesting theory I have about bioluminescence of living cells, and how plant cells and human cells, anything living, has a glow to it, like a luminosity. And I was thinking that there is some teachings out there that suggest Adam and Eve were like light, like that's what they were clothed in. And when they sinned, they lost their light, and they thought they were naked, and they wanted to clothe themselves with something. And it brings me to a scripture, Isaiah 6, verse 3, where it says, "Holy, holy, holy is the Lord of hosts. The whole earth is full of his glory." And if the whole earth is full of his glory, I was thinking that perhaps everything alive or living would be glowing, like all the flowers, the plants, would be different colors of light, or animals and people. What do you think about that?
Well, think about this. Have you ever seen those creatures in caves that produce a luminous? They essentially create their own light from their body inside the cave in order to be able to see and move around and things like that. And the same thing's true with things in the deep ocean. So when there is no light source, um, things find their own way to create light. The same thing's true with humans. We were living in darkness. We wanted to figure out how to use light, so we made fire. That's one of the simplest reasons for creating fire, is to be able to light your path. Now, it would probably be safe to say that every cell does emit light, and at a point in which an amassing of 0 point energy is no longer occurring, that light would then be traveling faster, and it would be possible for cells and membranes and skin and things like that to glow.
Well, this is all very fascinating. Thank you, Mr. Trone, for joining us tonight, and you've given us all a great deal to think about and ponder about, and we hope to have you back soon. Thank you very much.